Hello everybody, welcome back to episode 23 of the video series in which we program an entire video game from scratch in the C programming language. Now last time we left off right here, and we were drawing our main menu, right? Before we continue, let's read the comments that I received since last time. So essentially, we had a couple of commenters that were trying to help me with the environment variable stuff. Since I was obviously struggling last time, I sort of fast forwarded through that part in the video. Of course, you know, it's all fixed now. The post build step is what I was trying to fix, which is right there. It's just I'm just telling Visual Studio that I want to run this batch file every time we compile. And the batch file for right now, the only thing the batch file does is copy the assets folder into the correct place. But we will expand upon it later on as we will eventually develop the need for additional post-build steps. Anyway, so the copy assets.batch file, if you're not familiar, let me find it and open it here. Users. The batch file simply, you know, like deletes that directory and then recopies it into the appropriate place. But it uses an environment variable, and the environment variable you have to set. So I have it set right there to be the name of the directory where the game lives. And the reason why is because, you know, so that you can download this from the GitHub repository and you don't have to change any hard-coded path names, because obviously, you know, you don't want my username in your path. It wouldn't make any sense. It doesn't work. So anyway, that's what that's for. And I use the setx command line utility setx to help achieve that. You can also do it in the GUI control panel, system, advanced, environment variables. You could do it from here as well. Setx is it actually sets the environment variable persistently so that it will stay, as opposed to if you just use the regular set command. It will only set it just temporarily for this shell, but not for any other shell. What else? Yeah, I suppose that's it. So let's see, what else do we have for comments? Oh, and the other thing is that you have to restart Visual Studio, which was, I think, something else that I forgot originally. Let's go to GitHub real quick. Build instructions. I put the build instructions there. Piece of cake. All right, next comment. Okay, this one, he says, this commenter says game input can be a structure which we can pass to the PPI functions, which definitely agree. So let's go ahead and knock this out right now. If you recall from last time, I basically duplicated all of this get async key state stuff in every one of these PPI underscore functions. And, you know, whenever you're programming, general rule of thumb is when you find yourself duplicating large swaths of code like this, you know, and I just like copied and pasted the exact same code in multiple locations. And when you find yourself doing that, you are generally doing it wrong. So, you know, it stands to reason. I don't want to do it like this, because if I ever update any of my processing player input code, then I would have to update it in multiple places, right? And I just don't want to do that. So what I'm going to do instead is I'm going to create a new data structure, and I'm going to call it game input, I guess. Game input. And essentially I'm going to take all of these variables. Oh, by the way, look at this. If you hold the Alt key down, this is a neat trick. Okay, so most of you know that if you if you hold the Shift key down while you move the arrow over, it will select as you go, right? But not as many people know that if you hold down the Alt key, if you click somewhere, hold down the Alt key, and then drag your mouse, you can actually drag like this, which blew my mind when I first learned about it a few years ago. But that works in Notepad++ as well, the same trick, and maybe other text editors too, I don't know. But anyway, I just copied that because I wanted to paste them into my game input structure. Just like that, and these as well. Now, since I'm making this into a global data structure, these don't need to be static anymore. So I can do the same little trick here. Alright, now I'm going to make a new global variable called game input g game input. Alright. Now I'm going to go find don't need that anymore. Don't need that anymore. I'm going to go to process player input, and I'm going to paste that into here, only it's going to be g game input dot escape key is down. Paste, paste, paste. Okay, let's go get those. Let's go get those static variables. actually, let's go get the gamepad input. Put that process player input. You know, we could probably put GGamepad ID inside of the GGame input data structure now. That would make sense. Okay. Process player input. We're assigning all this stuff. Yeah, and by the way, the commenter originally said that we could make a structure that was local, like we could make a structure that was local to the process player input function and then pass it as a variable to each one of these functions, and that would work fine as well. That may actually be a better idea. I may move to doing that some other time, but as for right now, I'm just going to do it like this. So we don't need any of this now. Need that. We'll go back to process player input. Paste, 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 paste. Okay. And wasting my time by vertically aligning these things. All right, that should do it. And now, now at this point, our process player input function is essentially finished. Like, it has served its purpose. It does what it's supposed to do, and the only thing left is simply as we add more game states to the game, we'll put them here. But that's basically all the process player input function does now, is that it basically gets all of our key states, stores all of the key states into our global input game state, game input data structure, and then just dispatches to the appropriate function to actually do the processing of the player input, depending on what state the game is in. And then finally, it's just saving off the values into the was down members of the data structure, so that we know whether the button was pressed or not on the last frame. So let's go and fix all of these. Delete all this. 0 errors, 0 warnings. Well, we got a few warnings just because we're leaving out some of the game states. Input still works. It's looking good. All right, excellent. So now, next comment. He says it's looking good. Another commenter says looks good. This other commenter says, like, you are so chill and knowledgeable. Thank you. It's like, okay, thanks, but don't make it weird, okay? Another guy says, thanks for making these. Another commenter says, I've spent months to search for C++ graphics without libraries. Is this what I'm looking for? And then I replied, well, it's not C++. It's pure C, but it is definitely graphics with no libraries. Okay, last comment. This commenter says, I have an issue within Visual Studio where all of my globals defined in my main.h are undefined within my main.c, yet I still have compile and run. But sometimes if I move the lines where the globals are undefined, then the error goes away, like moving the line down one and then back up. And when I hover over the global, it shows the value is assigned with. I hope this makes sense. Yes and no. I think I know what you're talking about. And I think your Visual Studio is jacked up, basically. If you're saying that the game still compiles and runs, so you're not doing anything wrong, right? It compiles and runs, so the code is fine. But you're saying Visual Studio is just being weird and telling you that you have errors when you don't really have errors. So what I usually do when that happens to me, and it does happen pretty often, if you've been watching this stream and paying attention, or sorry, it's a video series, not really a stream, but I always get them mixed up. If you've been watching, you've known that I do kind of struggle with Visual Studio quite a bit because Visual Studio likes to break, like IntelliSense breaks all the time, and like it tells me I have errors on like in like really stupid places where like it'll tell me like some of my comments are compiler errors and stuff, and then the errors will just like magically go away on their own. Now I haven't had to do this, but if you close Visual Studio and you go find your project, and it's in source, repos, game B, you see this .vs folder. Now you'll have to display hidden items in order to see it, but this .vs folder is like Visual Studio metadata, and it's comprised of things like precompiled header. I think that's what PCH stands for, right? Is precompiled header. But and like this vc.db database file that's enormous, it's like 34 megabytes. I think that's the IntelliSense database. I don't really know, but sometimes that data gets corrupt. It gets jacked. Just delete it. Okay. Try that. Give that a try. Delete that whole directory, and then when you restart Visual Studio and reopen this project, when you do that, Visual Studio will regenerate all of this metadata and regenerate the database and all this kind of stuff. That will probably make all of your errors go away. Okay, and that does it for the comments. So let's see, what have I done since last time? I did fix the SSE2/AVX precompiler directives since last time. And what do I mean by that? I mean, if you go down here, for example, all the way down towards the bottom, I basically just fixed this where it's like if AVX is defined, then use this clear screen function. Otherwise, else if SSE2 is defined, and notice I changed the name from SIMD to SSE2 because see, both of these AVX and SSE2 are both different versions of SIMD, right? So I just changed the naming convention to where it makes more sense. Else, if neither AVX or SSE2 is defined, then just use your regular clear screen function like that. Now, I only did that. The only reason I did that at all is simply to sort of like give a brief introduction to SIMD intrinsics. In the real world, in practice, it really isn't going to make any difference at all, really, because the compiler, I think, is already going to be smart enough to optimize. Like, even if you use this version of the function right here, especially in release mode, it's going to be smart enough to use. It's going to be smart enough to use whatever SIMD intrinsics are available on your processor anyway. So this isn't really necessary. It's not that necessary or beneficial for me to be doing this right now. I was basically just doing it for demonstration purposes. So we may actually end up ditching this later on anyway, but I don't know. All right, so fix that. So I get rid of that. Added number of CPUs and processor architecture logging. Basically during startup, I just added a little bit more logging, which, looks like this. Game B is starting, number of CPUs 4, CPU architecture x64. If I went and built this in x86 mode, it would show that right here. So, that's kind of useful for, if you're troubleshooting on someone else's machine, they're like, hey, this game isn't working. You'll be able to tell, kind of some details about their machine. This is basically just telling us that it's loaded all these bitmaps successfully, etc. So, as you know, I like my logging, so I like logging things. Okay, fix the post-build step with the environment variable thing. We already talked about that. Okay, create a global key state structure or structure that is local to process player input. We just did that. Okay, show what happens when we don't use memset to clear the screen every frame. All right, so if I go down to draw title screen, right here I'm clearing the screen. With that memset command, I'm clearing the entire screen to black by setting every byte to 0. If I don't do that, what do you think will happen? Let's see. All right, so first we have a gray screen, and now notice as I arrow down, it leaves it leaves a trail of everywhere that the cursor has been, so it's not erasing the screen every frame. If I had more motion, like if I switched to the other game state where my character is walking around, he would create like a snake, a ghost, a trail behind him as he walked around. That's really it's pretty simple, pretty easy to understand. So later, as we develop this game, we may develop a system where we only redraw parts of the screen that have changed. That would be like really smart, 200 IQ level stuff. If, instead of clearing the entire screen every frame and redrawing the entire screen every frame, what if we just invalidated parts of the screen and redrew only the parts of the screen that we knew had changed? We could potentially save a lot of CPU cycles if we did that. But on the other hand, given that this game is only 384 pixels by 240 pixels high, it's very small. Is it really going to matter? I mean, if we're already drawing at 3,000 frames per second, I don't know. It's a lot of work for something that we're never really going to see the benefits from. Now, if I was drawing something at like 1080p resolution or 1440 resolution or 4K resolution, at that point it would become really important, because your CPU would really start to struggle to keep up and stay at 60 frames per second. But given that we have such a small resolution, it may or may not be worth it. That will definitely be on the list of things to do for optimizing the game later, after we're kind of more done with the game, more finished with the game. But at this stage, at this early on, it's so early on to really start doing those sorts of optimizations. So it's not really important. Okay, the next one, show what happens when we don't use the was down keys. So essentially, if I go to process player input, which is right here, and essentially I'm just showing you these things because so that you are really certain why I'm doing it. I want to show you why I'm doing what I'm doing, right? That's what makes this valuable. So let's pretend if I don't assign these was down values, so now I'm no longer keeping track of what was the state of the key on the previous frame. We'll see what happens. So this is my title screen, and see that now what happens is when I click a button going up or going down, it cycles through so fast that it basically iterates the entire menu up and down. So for instance, it takes me more than 4 frames. My finger stays on the key, and the key stays depressed for more than 4 frames, because it's only 15 milliseconds per frame. So we're talking 15, 30, 45, 60 frames, 60 milliseconds or something. So if your finger stays on the key for 60 milliseconds, you'll blast through all of the menu items, and you can't control it. You can't. There we go. I can sort of if I try to click really fast, I can sort of yeah. You'll just have to play with that yourself, I guess, if that's not clear enough. But that's why I do what I do, because this input is getting processed every single frame, and we want to make sure that we're not doing that thing that I just showed you with the menu. If there are other ways that we could attack this, in this sort of game where it's just like an RPG, it's probably not that important that our inputs be perfect to the frame. But if you were making an action game, if you were imagine a fighting game like Street Fighter, for example, in a game like that, it is super important that your controls be absolutely perfect to the frame. So yeah, that's basically why I'm using. That's why I'm keeping track of the previous key state, so that I can do things only do this if the key was not down on the previous frame, right? All right, so hopefully that's clear. I just wanted to show you. Show what happens when we don't use local frame counter. Well, we haven't really gotten there yet, so I'll save that until later. Add movement speed. Alright, don't really care about any of that other stuff for now. So I think I promised you guys last time that we're going to get into sound. So we are going to get into sound this game. Now that I've spent half the episode on other stuff, we are going to get into sound. And we are going to be using X Audio 2. See, look, why is this dark right here? Why is this darkened? And this is darkened. It makes no sense. I just don't know what Visual Studio is doing. I mean, they've made so many versions of Visual Studio that you think that they would have caught these kinds of bugs at this point. They're just Visual Studio bugs, and that's probably what the commenter, that previous commenter was talking about. And you just have to power through it. Visual Studio has a lot of bugs, and you just have to power through it. Let's see. Okay, so we want to do audio. I'm going to include a new header file called xaudio2.h. Now, does that build? Let's see. We also need to include the library. You know, I always like to forget the libraries. We have to link against this library too. Comment library xaudio2.lib. I think it might be, there might be like a version number. I don't know. All right, now first let's see if it compiles with that header file in there. And it does. Okay. So I can't really, I can't say that we're not using any libraries to make this game, because we are technically, we're using an audio library and an input gamepad library, but we're very minimal library use, right? All right, so now let's make a new function called. Let's make a new function called initialize sound engine, and I think it's going to return something. If I remember correctly, most of these functions return H results, so our function is going to return H result also. Let's do a little research on xaudio2. Why did I pick xaudio2? I picked xaudio2 because the all right, let's just read about it. It's a low level or lower level API for Windows. It's the successor to Direct Sound, which is why I didn't want to use Direct Sound, because Direct Sound is really old and xaudio is the newer one, and xaudio has compatibility with Xbox. So if I ever wanted to port this game from Windows to Xbox, this is just one less thing to worry about. Okay, so yeah, you can read about it. It's, of course, it's got documentation, and xaudio can do a lot of things, and we're not going to be using most of xaudio's capabilities. We're just going to be using it to play sound effects and background music. But yeah, if you go through here and read this stuff, I mean, it tells you how to do most of all this stuff, like how to initialize it, how to load audio data files. And you can see here there's plenty of source code examples, and it's just like what we did for the bitmaps, where we're gonna go in, we're gonna find a WAV file on the disk, we're gonna read the bytes out of it and make sure that it's right, and we're gonna load the metadata and all this kind of stuff. But let's not get ahead of ourselves. We have to initialize our sound engine first. Go ahead and make this function, and SOK. Now you'll notice that on a lot of these other functions that I've written that return like a D word, for example, I'll use something like error success, and it literally doesn't matter. Error success is defined as 0, and SOK is defined as 0 as well. It's just that I'm trying to stay consistent with, like, I'll show you what I mean. The first thing I'm going to do inside this function is I'm going to call co-initialize ex. And this function is simply, it's a Windows API function that you call anytime you are about to start interacting with COM, component object something or other. What does COM stand for? Component object model something or other. COM in Win32. Component object model. It's essentially terrible, awful technology that I really hate. Code, but you have to use it. It's like a necessary evil in Windows. So I know that there are certain people in Windows, like Larry Osterman, for example, who think COM is awesome, and he wrote a lot of COM. I think he invented a lot of it. Super smart programmer, but COM, in my opinion, is sort of like, I don't like COM for the exact same reason that I don't like C++. Generally, and generally speaking, it's like I don't see the need for it. I don't see why it needs to be as complicated as it is. I think that everything that it does can be done much simpler and in a much more lucid manner. It's like, I'm trying to think of a good vocabulary word for just overly complex, needlessly complex. Anyway, I'll stop going on about it. But like I said, if you're going to do much in Windows, you will probably run into COM at some point. You can't avoid it in Windows. You can't really stay away from it for too long. So anyway, Xaudio 2 is implemented as a COM, basically a COM server, I guess you would say. So if you're going to interact with Xaudio 2, you basically have to interact. You have to basically mess with COM. And so this co-initialize ex function, that's how anytime you're about to interact with a COM interface, you have to call this function once per thread. Like every thread that you're going to interact with COM, you have to start by calling that function. So let's see. We'll do if result is not SOK. And so that's the whole reason why I'm returning H result right here, is because all of these functions, they return H results. And since all of these functions return H results, I'm going to return H result as well. And so, I'm going to make these functions just like I make all of my functions, same sort of pattern. I'm going to log this error. It's been so long since I logged any errors. Log level error, cannot continue. Okay, let's see. Co-initialize ex failed with %8ls. Okay. And I'm going to go to WinMain right now, and I am going to initialize the sound engine somewhere in here. I guess towards, after I create main game window, I'll do it right here. If initialize sound engine does not equal SOK, then we cannot run the game, we fail, we notify the user, and we exit. Initialize sound engine failed. All right. Initialize sound engine. Okay. So this is actually pretty simple. We need to use X audio to create, and we need to supply a pointer to this interface thing, which we need to make. So go way back up here. We are going to create a new global, and we're going to call it. It's an X audio 2 thingy. We need to create an IX audio 2, a pointer to an IX audio 2, and we're going to call it GX audio. And while we're here, we're going to make some more variables too. IX audio to mastering voice, GX audio mastering voice, and IX audio to source voice, GX audio source voice. Okay, let me think about this. So X Audio 2, and you can read about this in the MSDN documentation that I was showing you earlier. X Audio 2 has this concept of mastering voices and source voices, and essentially all you really need to know, or I should say the short version of the story, is that the source voices are the ones that your sound actually comes from. So what I think we need is we need a source voice for the background music, which we only need one because we're only going to play one background music track at a time. So that's going to be our background music source voice. And then we need a sound effects source voice. And I think if we're going to have, if we're going to allow more than one sound effect to play simultaneously, then we need more than one source voice for the sound effects, because we may play multiple sound effects at the same time. We may have overlapping sound effects at the same time. So let's make a constant. Let's make a constant, and we will call it. We're going to make a pound defined number of sound effects source voices, and it'll be 4. So my thinking is that we'll be able to play up to a maximum of 4 sound effects at a time, which is probably better than what the original NES was capable of, if I'm guessing. Alright, we created our IX Audio 2 interface. We created a IX Audio 2 mastering voice. We need a source voice. I'm going to make this an array because we're going to have multiple number of there. Now we have 4 of them. We need a source voice for the background music as well. So we're going to call this IX audio to source, GX audio source audio SFX source voice for the sound effects. We need another one, IX audio to source voice. We need another one for the background music source voice. We only need one. Alright, I think that's good. We're probably going to need a little counter. We're going to call it SFX source voice selector. And it's basically, this variable is going to be the index into this array right here. So it's just going to be like, if our sound effects source voice 0 is already playing, then we're going to play the next sound effect on source voice 1. And then we're going to play the next sound effect on source voice 2, and we're going to play the next sound effect on source voice 3, and then we're going to loop back around to 0. That way we can have a maximum of 4 sound effects playing simultaneously. That's the theory anyway. I think that's going to work. I think that's going to be fine. Alright, so let's go back to initialize sound engine. Okay. Now we have X audio to create. I think he needs our GX audio interface. Now, I just noticed this definition of X audio to create for desktop apps targeting RS5 and newer. I am going to ignore that because I know this works on older, like you can get this to run all the way back to Windows 7. So I don't know why that says RS5 and newer. I'm just going to ignore that for now. Initialize sound. Flags is 0, and then X audio to any processor. And if you go and look this function up, yep, returns a pointer to an IX audio to object. The flags is not documented. Well, this function is not documented very well. The DirectX SDK versions of Xaudio 2 supported a flag debug engine to select between the release and checked build. This flag is not supported in Windows 8. Yeah. Now, I remember seeing, I guess, an older version of the documentation where this was documented. But essentially, all this is saying is the flags is going to be 0, and then any processor means that since Xaudio 2 is inherently capable It's multi-threaded aware, so if you have multiple CPUs, you can play music and sound on many different processors. And that's something that you'll notice now, is that once we start playing these sound effects, if you were to look at our game using Process Explorer, or actually even in the Visual Studio debugger, you will notice threads being created. Now that we've introduced COM and we've introduced Xaudio 2, you're going to be seeing new threads being created within our process. And these threads are essentially a thread pool that is going to be used to play sound. So this means that the sound is going to play asynchronously on like a different thread other than the thread that we're using to, like, say for instance, draw or render our graphics. And that's generally desirable because you wouldn't want your sound effects slowing down your game, getting in the way of your game, or like stuttering if if the graphics are drawing slowly, or if we because in our main thread here in our WinMain function, in our main game loop, right there, we're sleeping. We're sleeping every single frame, right? If we put the thread to sleep, that means our audio would stutter. It would stop playing. It would stutter, and we don't want that. We would want our sound and our music to be playing on a separate thread. So that's exactly what's going to happen. How much time do we have? Okay, we're already getting close on time. I'll at least try to get this initialize sound engine function finished. Okay, so when you're working with COM interfaces and you're working with H results, there's a macro that you're going to see a lot in Windows programming. This little macro called failed, and it basically just, what does it mean? It basically means if it's less than 0, then that means that it failed. We go to exit. We have to log a message here, and we're going to say Xaudio 2 create failed with that message. All right, on to the next. We're going to we have to create our mastering voice first. So Xaudio virtual table. This right here is like a weird little step that we have to do because we're using C instead of C++. Create mastering voice, and it needs this. If we were using C++, this is where the concept of we would be typing this keyword. But since we're not using C++, and we're using C, but Xaudio is inherent, like Xaudio is meant to be used with C++. It's not really meant to be used with C, or it's one of those things where Microsoft assumed, why would anyone be using C? But that's what we're doing anyway. So we have to type type all these redundant things. We need to give it the address of our mastering voice, Xaudio mastering voice. Input channels is just going to be the default Xaudio 2 default channels. And then sample rate, again, we're just going to make that the default Xaudio 2 default sample rate. And then an effect, what is this, flags? No flags. No device ID. I guess if you had multiple sound devices, it's just going to be the default sound device. An effect chain, we're not going to have an effect chain. And then stream category, We don't care about any of that stuff. Okay. And again, if that failed, then we shall report the error and exit the game. See if this still compiles. We will get rid of those by x audio2.h. We're going to take that out here and we're going to move that up here where we have temporarily disabled warnings. That should get rid of those. Visual Studio, man. Alright, initialize sound engine. Let's go back to initialize sound engine. Okay. So we have to, all right, so we're going to start creating our source voices now. And we're going to create a source voice for our sound effects. Now, how are we going to create our sound effects is another question. I need BFXR, I think is the name of it. So I was just, searching for random things that you can use to make sound effects. And I came across this little application, BFXR. So I'm going to download it. Show in folder. Unblock. Copy. Paste. BFXR. Ooh. Now let me scan this for viruses real quick, because downloading stuff off the internet, got to do your due diligence. Downloads bfxr.exe. 072, so it looks clean to me. It looks pretty clean to me. So I'm going to run it. Okay, now this is, I apologize if this comes out really loud. I have no idea how loud this is going to be. So please, I'm going to turn my speakers down. You might want to turn your speakers down too. Okay. Not bad. Okay, so this little app, I just downloaded. It basically just uses a lot of randomization, a lot of randomizing algorithms to make sound effects. And you can make all sorts of different kinds of sound effects. All right, cool. So I'm going to use that sound effect. My end goal is to use this sound effect as the menu sound effect that plays when we cycle through the menu. So I'm going to hit export wave, and I'm going to save it in, where am I going to save it? Users, my username, source, repos, game B, assets. and I'm going to name it something like menu select.wave. Save. So now, if I go to that location, source, repos, game B, assets, menu select.wave. If I go to properties, this file came from another computer. It might be blocked to help protect this computer. I don't know why that triggered that, but if I go to details, we'll see that I have a bit rate of 705 kilobits per second. Now I thought it would tell me, maybe I need to open this. I probably need to open this in a smarter program. So have you ever heard of Audacity? I need to install Audacity. Audacity for Windows. Okay. Recommended. Download. Okay. Download it. Okay, now that Audacity is installed, I'm going to load that sound effect that I just created. Users, source repos, DB, assets, menu select.wave. There's my sound effect. Now, the only thing I wanted to show you, well, first I wanted to play it. Okay, the only thing I wanted to show you is that it's mono, not stereo, but mono, and it's 44 kilohertz and 32-bit float, which I don't really know exactly what that means, but there you go. We're going to need this program anyway, so I had to install it. Save project, no. I was going to need that. I was going to need Audacity anyway, so I figured now would be a good time to install it. But back to the code. We're going to need to create something here. We're going to create a wave format EX, and we're going to call it sound effects wave format. Might as well create one for the music too, huh? Okay. Yeah, so this data structure is not actually part of Xaudio 2. This is actually part of the multi, whatever that API was, that MME API, include mmreg.h. Yeah, so it's just like a It's a data structure for describing wave files, essentially. Okay, SFX wave format. We're going to fill it out. Format tag equals wave format PCM. We're going to do format.channels equals 1 mono. So I think we're going to have mono sound effects and stereo music. SFX wave format dot in samples per second equals 44,100, and I'm choosing these values based on that wave file that I got that was generated from that application BFXR. SFX wave format dot average bytes per second equals SFX wave format samples per second times SFX wave format dot channels times 2. SFX wave format dot in block align equals channels times 2. SFX wave format bits per sample equals 16. SFX wave format dot CB size 0x6164. And if you go to MSDN, it will tell you that this is ignored with PCM formats, so it doesn't really matter what it is. Make sure I typed all that correctly. 1 samples per second, average bytes per second, samples, channels times 2, block align, 16. All that looks right. Okay, so now we're going to create 4 voices. We're going to create 4 source voices for our sound effects. Create source voice. Our X audio interface. We need the address of GX audio sound effects source voice counter. It needs the format that we just specified, wave format. It needs a flags, it's 0. We need a max frequency ratio, which is just going to be the X audio to default. And then we need nothing, all this other junk. Voice callback we don't need. Send list we don't need. And effect chain we don't need. So, as I said before, we're not going to be using much of the capability of X Audio 2. We just need a very basic engine to play wave files. And our sound effects are going to be in wave files like this. Our music, I don't know if our music is going to be MP3 or OGG Vorbis or what. It might just be wave 2. I haven't decided yet. But yeah, there we go. I know we're over time, so I'm just trying to finish this real quick. If result is not as okay, then you must quit. We need to log this error. Create source voice failed, and then you have to leave. You know what? We should probably... Okay, so after you create a source voice, we need to set the volume of it. The volume is definitely going to be something that the user can configure, but we need to create a global for it. I guess we're just going to call it... I think it's probably a float. We're going to call it GSFX volume. And for right now, we're just going to set it to 0.5. GX audio, sound effects, source voice, counter. And then each one of these has functions. Set volume. GX audio, sound FX, source voice, counter. Did I type that incorrectly? Yes, I did. There it is. Which is, again, this is like essentially the this keyword. I should just be typing this, but I can't do that because we're writing C and not C++. And I'm going to set it to the sound effects volume, and I'm going to say commit now. Does it run? It does. It runs fine, which is nice. Okay, let's make one. Oh, we already made one for music, so let's go ahead and fill it out. Okay. Music wave format. Tag equals wave format PCM. Music wave format dot channels. The music will be stereo. Music wave format dot samples per second is the same, 44,100, which is it's in hertz, right? So it's about 44 kilohertz. Music wave format average bytes equals samples per second times channels times 2 format dot in block a line equals channels times 2 format bits per sample equals 16 and music wave format dot CB size equals 0. Alright, we only need to create one source voice for our background music, GX audio, LPV table, create source voice, GX audio, address of our GX audio 2 or GX audio music source voice. We're specifying the address of our music wave format, data structure. We don't need any flags. We need X audio 2 default frequency ratio, and then we don't need this, we don't need this, we don't need that. Result is not. That's okay. We need to log the error and exit. Oh, and don't forget to set the volume, our music volume, GX audio, music source voice, set volume. We never made a volume, did we, for the music? I think you should be able to set the volume of your sound effects and music separately. Music volume equals 0.5F. And again, these are just defaults. We're going to load those from the registry so that those values can be saved, so that you don't have to reset the volume every time you start the game. Anyway, GX audio music source voice, G music volume, and operation X audio 2 commit now. Okay, that's it. Our sound engine is initialized and everything still runs. So the only thing that we have left to do now is we actually have to load that file, that wave file, and then point our X audio interface or our source voice at it and play it. So next time we'll be making new functions like load wave from file or something like this, and like probably a play sound function, and then the play sound function will play whatever sounds you specify, and it will just, as I mentioned earlier, it'll play it like on our source voice 0 or source voice 1 or source voice 2, and it'll just cycle through our 4 sound effect source voices. So you can theoretically play 4 sound effects simultaneously. And as I said, that all of that will be taking place on other threads that are supplied to us by X Audio from the X Audio library. But we are completely out of time, so can't go any further today. So that concludes today's episode. As always, thank you for watching, and if you have any questions or comments, please do not hesitate to leave those questions or comments on the video. And of course, don't forget that we have a GitHub repository that goes along with this video, and I keep it updated in step with these episodes so that you can follow along. And that is all I have for you today. So until next time, thank you. See you next time. Bye.